Advanced Maths Paper 1 2021, question 4, memo with explanations. It's not going to help you very much merely watching this video or reading through the memo. You really need to practice yourself. So here's some suggestions for effective revision. Don't practice questions which you firmly know that you can do. Rather, selecting the questions on topics where you know that you will have difficulties. The only time you start practicing full papers is when you're trying to reduce your time taken to do the paper. If you become stuck in a question, yes, watch the video. Then it's vital you attempt the question yourself, preferably a day later, in order to test your understanding rather than your short-term memory. The very best way to revise maths is quality as opposed to quantity. It's more effective to complete fewer revision papers completely and correctly, ultimately without having to refer to help of any form, than to complete as many papers or exercises as possible. And the Confucius saying, which sums that up: what I hear I forget, what I see I remember, what I do I understand. Here we go. Prove that 3 to the 2n plus 4 minus 2 to the 2n is multiple of 5 for n element of natural numbers. This is your mathematical induction question, which hopefully you're going to get in every paper. So step 1, we need to establish that for n equal to 1, this is a multiple of 5. Step 1, the first rung of the ladder. So I substitute. We end up with 725, which clearly is a multiple of 5. Now, the next step of the mathematical induction process is that you say, well, assume it's true for n equal to k. And that means 3 to the 2k plus 4 minus 2 to the 2k is divisible by 5. Now, here's a useful technique. Make it equal to 5p, where p is a natural number. And we can use that. Now we go to the n equals k plus 1. And we're going to substitute k plus 1 for n, and hopefully to break it down and show, using the fact that this is acceptable, that when n equals k plus 1, that's also acceptable. So there's the substitution into the original using k plus 1. Now I'm going to break that down. I'm going to try to get that form so that I can just write 5p. So I multiplied out the brackets. So we're there. Now I need 1 3 to the k plus 4, not 9 of them. So that would be 8 times 3 to the k plus 4, plus 1 of them. And I need minus 1 2 to the 2k. And here we have 4 of them. So first of all, this is equal to 3 to the 2k is equal to 5p plus 2 to the 2k. Let's do it that way, because then we have 2k plus 4. You see, we can remove the having two different bases. So I'm going to put 5p plus 2 to the 2k instead of 3 to the 2k plus 4. Multiplying out is just a case of proving that this is divisible by 5. Clearly that is, because it's 45p, where p is a natural number. Well, have a look. This is 5 times 2 to the 2k. I can take out a common factor of 5, and there we are. It's got to be a multiple of 5. So therefore true for n equal to k plus 1, and we can make our final statement. Therefore, by mathematical induction, true for all n element of natural numbers.